Welcome everyone. Thank you for coming along and joining our webinar today, which will cover off new weather models that we have introduced to the PredictWind ecosystem. With that, I will hand over to Arnaud to do his presentation. Thank you very much.
Thank you very much, Nick. So I am going to share my screen right now. So today we're going to be together for 1 hour, and PredictWind, we are very excited to introduce you those 3 new weather models that you can see right now on the screen. So what is the outline for today? So in part 1, we are going to look at what is a weather model. So we will start by talking about NWP, which is a traditional weather model. And then we will move into artificial intelligence weather model, which is a new thing. After this theory, we will jump into the good stuff. So part 2, we will show one new AI model that we are offering our customers. It's called AIFS. It comes from ECMWF, the European Center. In part 3, we will show the new PredictWind AI model, which is called PWAi, and we are really excited about this model. In part 4, we will move away from AI model and we will talk about the model called ICON. It's a traditional one, but it comes from the German Met Service and it is focused on the Europe. And finally, we've kept the best for the end, part 5. So hopefully you stay with us until the end, and we will actually see in practice how can you use those new weather models for your sailing on the water. So let's start right now with the theory, the weather models. So first of all, I would like to let you know that this part 1, is actually available online as an article. So if you go to our help center, help.predictwind.com, you will find a section called Marine Meteorology, where you have 6 classes. It covers very different topics. If you want to learn about clouds, sea breeze, or other topic, please go there. But article number 1 is the weather model. This is a theory. So after this webinar, you can go there. And also please note that you can change the language. It's of course in English, but you can also read these articles in French, in Spanish, in Italian, and also in German. So now let's talk about NWP. It means numerical weather prediction. So this is really the traditional way to do the forecast. So if you've been checking the forecast for the past year, 10 years, 20 years, 30 years, this is the weather forecast that you know. So for some people, it's still a bit of a black box. Some people don't understand how it works. So I like to explain it with a simple image. The way you can look at NWP, it's like baking a cake. So what do I mean by this? So when you want to make a cake, you need to start with ingredients. And it's the same for a weather model. You need to know the current state of the atmosphere. Then step 2 is to follow a recipe. In the case of the model, we are talking about mathematical equations of fluid mechanics. Then you need to bake your cake, and we do this with a supercomputer. And finally, you get the cake, which is the weather forecast. So now I want to drill down on those 4 points so it really makes sense and everybody is on the same page. So by the ingredients, so step 1, what do I mean by this? So the big concept is to forecast the future, you first need to know the weather right now. So this starting point is called in meteorology, initial conditions. So a question you may have is, how do we know the weather right now? It's quite complicated, but here is how it's done. There are those sensors all around the world that measure the atmosphere. So for example, on land, we have those land-based stations, we have some rain radar. If you go on the water, you've got buoys, you've got ships. In mid-air, you've got aircrafts, weather balloons, And even if you go to space, you have some satellites that measure, for example, cloud cover, the temperature of the top of the clouds. So all those sensors, all the data is put together, and it makes what I like to call the snapshot of the atmosphere. So this is quite complex. It's done 4 times a day at midnight GMT, 6 a.m., noon, and 6 p.m., all around the world. And something that I would like to add, because it's quite important, is it's so complex that different institutes, for example, the American GFS or the European ECMWF, they make those initial condition files every day, but it's so complex that in fact, those files are a bit different, okay? Initial conditions is a tricky thing to do. Anyway, once you have the ingredients, you need to follow the recipe. So there is one simple equation that all numerical weather prediction models follow. This is this one. So the forecast is what's happening now plus a function times a time variation. So if I apply it to the wind, if I want to know the wind in 10 minutes, it's equal to the wind right now plus the wind variation times the time step, which is 10 minutes. And of course, the difficult thing is this one. How do you know this function? So we are lucky. There are some complex equations that were found by very smart men. I put the name here on the screen. And those equations, they tells you the variation of those weather parameters. So I'm going to be honest, those equations are complex. We actually do not need to know them or even to understand them in order to check a weather forecast. But I'm going to put one equation on the screen so we can just break it down and have a feeling of what the equation means. So this equation, for example, what do we have on the left-hand side? On the left-hand side, this is a derivative over time. So this is actually the variation of the wind. Maybe you notice it is a U because this is a zonal wind, the wind blowing from the west to the east. What is it equal to? So there is this big term, it's called advection, but advection just means transport of the wind. So this term, for example, it just tells you that if you are right here, right now, and you've got 10 knots, if on the west of you, you've got more wind coming, like maybe 12 knots, your wind is going to increase by 2 knots. Then we have another term, maybe you guys are familiar, which is the Coriolis force, which is a function of the rotation of the Earth and also your latitude. We then have a very important term, the pressure gradient. And finally, we've got the friction. If we are at the surface of a land or water, the wind is slowed down because of the friction. Anyway, I hope, once again, we don't need to remember this equation, but we understand that this is not a black box and there are some equations in the background. So let's move on. Those complex equations need to be solved everywhere in the atmosphere. So we divide the atmosphere in little boxes, and we are talking about grid points like this. And the spacing between 2 grid points, this is the model resolution. As an example, ECMWF has a resolution of 9 kilometers. So now that we know the recipe, we need to do the cooking, the baking. Okay, so in our case, we need to use a supercomputer to run those equations for every grid point, for every time step, during the entire length of the forecast. So this is what we need. And of course, as you can imagine, this requires a lot of computing power. So if I go back to ECMWF, this one has 9 million grid points. The time step is every 7 minutes, okay? And the total length of the forecast is 10 days. So those supercomputers need to make 18 billion grid point updates, and this is for all weather parameters, the wind, the pressure, the temperature, and so on. So as you can realize, this type of calculation requires a lot of time. It takes about 1 or 2 hours to calculate. You require a lot of electricity, a lot of energy, and of course, it costs a lot of money to run this. So finally, after all of this, you've got the cake. So the cake is the forecast output, and it is distributed in a format called grid, like this one. PredictWind, for example, download the model output twice a day. For example, ECMWF at midnight and at 12 GMT. Also, I want to point out that PredictWind, we run our own weather model. We do have this supercomputer as well, and we call it PWG and PWE, and we also run them twice a day. And here is an occasion to tell you why is this G and why is this E mean. So we just have one model, but we run it on initial conditions, so the ingredients from the GFS. In this case, we call it PWG. And if we run with the initial conditions from ECMWF, this is PWE. So they just show you how important are those initial conditions, because if they are slightly different, the output will be different. So after doing all this hard work with the calculation, we finally can eat the cake. And for us at PredictWind, eating the cake is really using the forecast, and it is sailing. So now that we have covered, this NWP, the numerical weather prediction, we want to discuss a new type of weather model. This is the AI weather forecast. So AI is a real revolution, and it touches every domain, and weather forecasting is also impacted. So how does it work? First of all, it's a complete different approach. So if you guys didn't like the physical equations I showed before, you are in luck, because those equations, you can forget them and put them in the trash. The way AI weather forecasts work is two-step. First step is you need to feed the model with weather from the past, so the model can learn the weather. And step two is you give the model today's weather, and it can make the forecast. All right, so this is a theory, but what does it mean? Learn the weather from the past. In order to explain this simply, I like to take an image once again. So this image is going to be an old fisherman. So please follow me. Let's take a fisherman that has been going out to sea for the past 50 years. If we meet him at the dock one morning at 6 a.m. and you ask him, hey, what is going to be the wind today at 12 o'clock? There is a good chance he might tell you 10 knots from the north, and there is a good chance he's going to be right. And the question is, how does this old fisherman can do a weather forecast? He doesn't have a supercomputer. He knows nothing about the equations, but he has all this experience, okay? So on a day like today, he's just going to look at the clouds. He's going to look at the boats. Is the deck of the boat wet? Mean it rained last night? What is the color of the sky? And he will use all of this, compare without even thinking about it, about all the past 20,000 days for the past 50 years, and he will be able to make a forecast. And really, the AI training, step one, is a little bit like the fisherman experience. Of course, an AI weather model is much more powerful, because it's not going to forecast just in the little bay of our fishermen. It's going to forecast for the entire world. And also, it's not just for today, but for the next few days. But this image, if you need to take something out of it, it's a good way. So now I would like to explain more deeply those two steps, the learning and also the running of the model. So the learning of the model, we use the word train. So training the model, we use a large historical weather database. So the one we use, or which is widely used, this is ERA 5. It comes from ECMWF, and this is the last 50 years of data, okay? It's older than me. So this database, for example, if you are in Auckland, New Zealand, you want to know the temperature on the 1st of January 2000, it will tell you. It's a global database. Then what you do is during the training, the AI weather model optimize its parameters to minimize the forecasting error. So me, how I like to think about an AI model, I like to think about it as a machine with hundreds of millions of knobs. And each knob is like a parameter, okay? And the training, it's all about finding the correct position for each knob, like this. This is the learning. And when all the knobs are set in the correct position, the model is ready. So once again, the training is a difficult part of an AI weather model. This is what it takes time. And then when the model is ready, it's actually pretty easy to run it. So this is step 2. So let's say I want to run the weather model for today. So I start with my ingredients or the snapshot of the atmosphere. So this is the same as the NWP. These are the initial conditions at 0Z. I feed it in my trained AI weather model, and it will give me the wind forecast at 6 a.m. Okay. And then in order to calculate for the next step, I feed this back into my weather model, and I will be able to do it for 6 p.m. the next day, and so on. So now we covered NWP and AI. Let's do a quick summary, a quick takeaway. So NWP, this is the equation. AI, this is our old fisherman. So how does it work? This one, it solves physical equation. On the contrary, AI, it learns the weather patterns from the past. In terms of explainability, this one, you can physically explain it. The AI, it's a complete black box. To be honest with you, no people can. In terms of innovation, and this is where it gets pretty interesting, is actually there is very little progress being done on NWP these days, little innovation. On the contrary, AI, it's very easy to retrain and create a new model. As an example, ECMWF is working on a new database of data to replace ERA 5 and with ERA 6. It will be ready next year. And when this is ready, we're going to retrain all those models and get better AI model. So this is why PredictWind, we believe in those AI model. Even if today they are not the greatest thing ever, they will improve drastically. An AI model in 1 year, in 2 years, in 3 years will be, in our opinion, very, very accurate. Also, a good thing about the AI model is how long it takes to run. So this one we said is slow, it takes hours, but the AI, it's very fast. It's like ChatGPT. If you ask any question, in about 1 second or 1 minute, you will have a forecast. So what do PredictWind offers? So in NWP, we offer all those models, PWG, ECMWF, GFS, and UKMO. We also offer ICOM that we will see later on. But in terms of AI, we offer AIFS and PWAi. So right now, we are going to study AIFS. So part 2. So AIFS stands for Artificial Intelligence Forecast System. So last year, maybe you've seen it, but big tech companies, they have all released AI weather model. Google, Windows, NVIDIA, they all have their own model. But, you know, they do not have any forecasting experience. This year, in 2025, the European Weather Center, ECMWF, that has 50 years of forecasting experience, has released its model, AIFS. And this is because of all this experience that PredictWind decided to actually go with AIFS and not those other AI weather models. So here is a comparison. On the left, this is ECMWF NWP model. And on the right, this is a new one, AIFS. So this one is quite old, it was created in 50 years ago. And this one was just launched. But what is interesting is those models, they use the same initial conditions. Those models are also run daily, and ECMWF compares those two models daily. So we really appreciate all the experience and all the daily check that they are doing. And what is the motivation of ECMWF for going into AI? This is the same thing. This one, as we said before, takes some time, takes energy, and takes money. But the new AI weather model, it's fast, it uses less energy. They quantify by 1,000 times less energy. It's cheaper to run. And once again, there is potential for innovation. So now we can discuss briefly how AIFS was trained. Okay, every company has its own way of training the model, and this is what makes a difference. The architecture, it uses a graph neural network, a little bit like the brain of someone. And GNN learns how things are connected, influence each other. So the way I like to think about it is the neurons are a little bit like the grid points of the Earth. And the GNN learns how neighboring grid points influence each other, just like how weather moves from one area to another. So remember, if my fisherman is right here and trying to make a forecast, he's just looking at what's happening around, and based on this, he can make a forecast. The training of the data also is very complex, and every company has their own way. For example, ECMWF, they are using ERA 5 until 2018, and then they fine-tune their model using actually the ECMWF NWP model. So once again, there is a lot of know-how with weather model, and this is why PredictWind believes in AIFS. What are the important things to remember about AIFS for a sailor? So the resolution, we are talking about 25-kilometer horizontal resolution, okay? The length of the forecast is 10 days, and the time step of the model is 6 hours. So now let's move into another AI model, the one from PredictWind, PWAi. So PredictWind, we have also decided to enter this revolution of AI weather model. We have a slight different approach, a very innovative approach, okay? We are actually using AI, but we are leveraging it with the proven reliability of NWP model. So I talked with the person that developed PWAi, and I asked him, is it like kind of a hybrid between AI and WP? He told me kind of, but not exactly. Anyway, this is how I remember it. We are actually mixing the two. I want to point out that the PWAi is now available, okay, but it's still on testing phase. We are still working on it in the background. And PWAi in numbers, so we have the same resolution, which is 25 kilometer. At the moment, the forecast length is only 7 days, but we are working to extend it up to 10 days. And something we have that AIFS doesn't have is the hourly time step for the first 2 days. So now maybe the question you have for me is, okay, how good are those AI weather models? So PredictWind, we are very used to comparing the accuracy of the model. We actually have a tool, which is a validation of model. But what we've done is we've conducted a validation study of PWAi by comparing the forecast with the observation. So how do we do that? We calculate something that we call the root mean square error. And simply speaking, this is just the error between the model and the reality. And of course, the lower the error, the better the model. And what we've done is a validation study was done everywhere in the world, and we have averaged this RMSE into one single error. So it's very easy to compare models. And the results that we have are very promising. We are very excited about that. And what we found at this early stage is PWAi is outperforming both AIFS, but also ECMWF and WP. So here is a graph that we were very happy to find. So this is for the wind speed. The axis is a day of the forecast from day 1 to day 10. And here, this is the error between the model and the reality. So what you saw, those two AI models are those two curves that are way below ECMWF. So what we can find is those AI model, in average, all around the world, they better forecast the wind speed. And if you look carefully, you will see also that the error of PWAi is slightly lower until day 7. This is one of the reasons why we are still working, because after day 7, AIFS is slightly better. So very promising results. We have done the same validation study, but for the wind direction. And here again, we can find that the two AI models have a lower error, so better forecast the wind direction. And we are very happy to see also that as the days go by, PWAi is also outperforming AIFS. So now we are going to move away from AI model for a bit, and we are going to talk about this new model, traditional weather model, which is ICON. So ICON, so what does it mean? It means icosahedral, and it comes from the German Met Service. And these words, I actually to look online, it just means triangle. So what's happening is earlier, we show you the grid. The traditional grid is little squares, rectangles, but ICON is using triangles. And the benefit of this is to have a more uniform grid, especially at the pole. And it's very efficient, especially to simulate the atmosphere, and especially true for high resolution weather. So ICON, in fact, is made of 3 models. We've got the global model for the entire world, but then we have regional model. They nested for Europe into a 6-kilometer resolution model, and they do it even with more resolution, and they got to ICON D2, which is centered over Germany, and it has a 2-kilometer resolution for the first 2 days. So what does it mean for you sailor? So this is ICON D2. So if you are sailing in the North Sea, like Germany, Denmark, Sweden, Holland, east of the UK, northern France, or even the northern part of the Adriatic, we recommend you use ICON D2 for your sailing. ICON EU, the 6-kilometer one, is all over Europe, even going down to Madeira right here. So it's great for sailing. So if you are, for example, in the Med, I will say like Greece, where our Rome 1 kilometer is not available. So if you are around here or next to Gibraltar, we recommend you use ICON EU. And the way I see it is ICON EU is just another source. It doesn't replace, but it's another model that complements ECMWF 9 kilometers. All right, so now we are getting into the last part, which is how to use those new models for sailing. So let's start with the AI models. So what are the strengths of this? So we have asked a lot of people, a lot of experts, and this is how we see the strengths of the AI model. What we found is those AI models, they tend to be quite good, especially after day +4, okay? They really tend to beat NWP. And so it's very interesting because it gives us sailors an early warning if a storm is going to happen, how to detect tropical cyclone or very strong wind. 4 days in advance, the likelihood is better captured by AI model. Also, for example, for hurricane track, there were some studies done by ECMWF, and the track, especially few days in advance, is more accurate with AI weather model than NWP. But the intensity of the hurricane is not really the case. More globally, we found that the synoptic trajectory is better, and in a certain way is more stable than ensemble. For us, for sailors, we found that when you do long passage routing, for example, crossing the ocean, especially after day 4, 5, 6, 7, the AI routing seems to be superior. But what are the limitations of this AI model? It's not all black and white. First of all, we need to remember that the AI has a pretty low resolution, only 25 kilometers. So really, AI model at the moment are not so great at forecasting well, for example, along the coastline. So for the sea breeze, the land effect, etc., especially for day 1 and day 2, we will still pay more attention to NWP, like PWG 1 kilometer, rather than AI. Also, what has been found is those AI, they tend to underestimate the strength of extreme events, okay, like the wind gust, the maximum rainfall, they tend to be on the lower side. And finally, AI is a new technology, so we think it's very important to know about this new technology, to look at the forecast, but it's still in the testing phase, and so take it with a grain of salt. Icon, as I said before, it's going to be a very good model if you are sailing in Europe. So if you are in the North Sea, it's a no-brainer. Go for Icon 2 kilometers. This is the highest resolution you will get. If you are in the Med, if you are outside the Arome area, go for Icon. And in the rest of Europe, you can have an alternative to ECMWF. So finally, where to find those 3 new models in the PredictWind platform? So if you go to the forecast menu on the website or the PredictWind app, you will find under tables, graph and maps, those models. So here you can find PWAi, ACON, and AIFS. So we display them next to the other weather models. If you click on the maps to the forecast options, you can also select AIFS, ICON, or PWAi. If you click on the update time right here, you will see the update time, and we have added all those AI model right here. Also, if you go to the weather routing or the departure planning, you will also have access to those models. So for example, here, we now have 8 routes. You can, if it is too many for you, you can click on hide and show, but you will find those AIFS and PWAi routes, which, well, as I said before, are quite good for long passage routing. And this is the feedback that we got already from some of our users that use those AI model for their passage. So I'm going to finish by this one. So this is a quote from a New Zealand customer, Kim, and he wrote to us 2 days ago. I used PWAi sailing down from Fiji to New Zealand last month. I was very impressed with its spot-on routing. Can't wait to see how much better it will get. So if you have feedback from our AI weather models, please reach out to us on support. We will be very interested in your feedback. Thank you very much.